So hi everybody and welcome to this 13th video in the solutions series. So in this video we'll go through elevation of boiling point. First, what is your boiling temperature? See, any pure liquid starts boiling at that temperature at which vapor pressure of the liquid equals to the atmospheric pressure. For example, water boils at, so that temperature is called as boiling temperature. Water boils at 373.15 Kelvin or 100 degrees Celsius because at this temperature vapor pressure of water is 1.013 bar or 1 atmospheric pressure. So since the vapor pressure becomes equal to the atmospheric pressure, so water starts boiling at this point. Similarly, ethanol boils at 78 degrees Celsius at atmospheric pressure. So this is your boiling point. The second piece of information you need to know is the vapor pressure of the liquid increases with increase in temperature. Okay, so what happens in the presence of non-volatile solute? Vapor pressure of the solvent decreases, right? Hence, what to do? Hence, the vapor pressure, hence the vapor pressure reaches atmospheric pressure at higher temperature. So this is called as elevation in boiling point. So graphically, if I have to show you, suppose okay, so let us resume here. So suppose this is your vapor pressure and this is the temperature. right? Now suppose for a pure solvent, if this is your vapor pressure at this temperature, okay. Now what do we know? As the temperature increases, the vapor pressure also increases, right? So your vapor pressure also increases in this. Now this is for a pure solvent, okay. Now for a solution, what happens? Since vapor pressure decreases, right? For a solution, vapor pressure decreases because it has a non-volatile solute with that. And even for solution also, as the temperature increases, its vapor pressure increases. Okay. Now, what is your boiling temperature? Boiling temperature is that temperature at which the vapor pressure of the liquid becomes equal to your 1 point. So, if this is your TB naught, I'll put it at TB star. Okay. So, which is a, if the at this 1.013 bar or 1 atmospheric pressure, or 1 atmospheric pressure, okay. So this is your boiling temperature. But for us, that was for pure solvent. What is this? This is your pure, not pure, it's a solution. Now the same, to attain the same pressure of 1.10 bar or atmospheric pressure, you need to go to a higher temperature, which is your which is your new TB. So which means your boiling, there is an elevation in boiling point. So TB, delta TB is the elevation in boiling point. So this was your, so temperature in Kelvin and vapor pressure in suppose bar or atmosphere. So that this is the scenario here. So also it has been found out that the elevation of, so diagrammatically you can also understand this. So depends on the number of solute molecules rather than their nature. So elevation of boiling point is also a correlative property. Okay. If TB star is boiling point of your solvent and TB is a boiling point of solution, your delta TB which is the elevation of boiling point, their elevation boiling point. Okay. So experimentally it has been found out that your delta TB is directly proportional to the molality of solute. See here, 2 represents solute, 1 represents solvent. Okay. Here, and delta TB is equal to a constant Kb into, where Kb is your boiling point, elevation or molar elevation constant, or abelioscopic constant, in Latin abelioscopy means boiling measurement. Okay. And the units of Kb are in Kelvin, kg per mole. Okay. So now what is M2? M2 is molality of a solute, so which is moles per kg of solvent, W1 divided by 1000. If I put both of these, okay, your delta TB kb into 1000 into root 2 1. Okay, if all of this is known, if your elevation boiling point is known, kb is known, this is known, this is known, this is known, and unknown, that is the molar mass of a solute can be calculated. Be calculated. So M2 being equal to so here Kb is given by so the value of Kb depends on nature of the solvent, so Kb is given by R, which is a ideal law gas constant, into molar mass 1 into boiling temperature of a pure liquid square into 1000 into delta vaporization H. Okay, so where R and M1 stands for, this is your gas constant, M1 is the molar mass of the solvent, okay, TB star is the boiling point of the pure solvent in Kelvin, and your delta vaporization enthalpy is the enthalpy of vaporization of solvent. So let me write it out. R is gas constant, M1 is molar mass of the solvent, TB star is boiling point of the pure solvent. Another solvent. Okay, now this elevation in boiling point was represented in terms of molality, right? This one. Now delta TB can also be represented in terms of your mole fraction of the solute. So wherein delta TB is equal to K into X2, where the constant K is given by R TB star square and delta vaporization H. So it can be represented this way as well as that way. So that was for elevation of boiling point. Thank you.